Hello and welcome to this video tutorial for the Forest Avian Communities Evaluation Tool, otherwise known as FACET. My name is Bartl-Geller and I'm the lead developer for this tool. To access the tool, you can navigate to tinyurl.com/facet in capital dash tool. That will take you to the tool. When you load the tool, it looks like this, and you'll have a modal dialog pop up that will give you some introductions to the tool and what it does. And here you can also access the tool manual by clicking on this link at the bottom of the dialog. There you'll find an exhaustive introduction, overview, and explanation of how the tool works, starting with the quick start guide, going into all the details that you could need about the tool. If you close this dialog and you want to access it again, you can click Help near the title, and that will bring that dialog back up again. Looking at this tool, there are two sections. There's kind of the display section on the left, and then there are all the settings that will be on the right. The first thing you'll need to do when using the tool is upload a shapefile. This shapefile will be the project area that you're interested in evaluating avian communities for. The shapefile can be one to many features, and it can be a small project area or a large project area. When uploading your shapefile, you need to upload all the files associated with the shapefile. You can't just click the .shp. That won't work. You need to instead select all the files for the shapefile, click open. That will upload the shapefile to the cloud, and the server will retrieve the backend data needed to run the avian community models on this area. You'll see a loading dialog that describes the progress of the tool towards getting that data, and this will take a little bit of time. With a larger project area, it takes more time. Once your project area loads into the tool, this is what the screen will look like. I'm going to give a brief overview of the different sections of the tool, and then we'll go into more depth afterwards. So the primary thing that you'll be looking at is this visualizations tab. This area on the left is going to be the pre-treatment visualizations, and then on the right will be the post-treatment visualizations. In the bottom, we have some information about the model that we're running. For example, this is a model of the California spotted owl, and we can have we get a measurement of the number of expected territories, pre-treatment and post-treatment. And I'll go into more depth about that when we talk about treatments. On the right, you can compare the mean occupancy across the national forest compared to this national forest. So this one has a mean occupancy of 0.27, and we have an occupancy range of about 0.3 to 0.6 in this project area. So this is the Visualize tab. Then there's also an Analyze tab. When you click on it, it'll take a few seconds to load. In a similar sense, we still have the pre-treatment and post-treatment, but instead of maps, now we're looking at summary statistics. So the mean occupancy is 0.49 in this area. And at the bottom, we have a comparison of our pre-treatment and post-treatment condition compared against a reference data set. And I'll explain that more in detail later as well. So let's dive into the visualization. On the right here is where you'll interact with all the settings. So the first thing is model parameters. This is where you can choose which species that you want to look at. There are over 70 species in this tool, and when you click on one, it will automatically update the models to show the species that you have selected. Similarly, the model data source lets you choose between using California Forest Observatory data or F3 Excel data. There are two different data sources because this will allow the tool to use the most up-to-date data that is available. As of this recording and the release of the tool, the CFO data and the F3 Excel data are for the same time period, but the CFO data is a higher resolution, so that's what we recommend you use, but refer to the manual for information about what is the most up-to-date data in the live version of the tool. Then the next menu is where you'll be able to input all your treatment information. The way that the tool thinks about treatment is thinking about prescriptions assigned to different treatment codes. So in the attribute table of the shapefile, there should be a treatment code column, and the that can be selected in this choose treatment attribute dropdown. So this will show you all the different columns in the shapefile and in the attribute table for the shapefile, and it automatically selects the column that has the closest to the word treatment. But if it selected the wrong one, you could select which one you want it to use here. Then the idea is that we'll have a unique set of treatment codes. For example, this one has treatment types of aerial, fuels, hand, and tractor, but you could have it could relate to a numerical code, 1, 2, 3, 4, 5, and you have a known prescription for each of those codes. It doesn't really matter as long as you know what your prescription for each code will be. You can also enter your prescriptions in imperial or metric by changing this radio button between imperial and metric. And if you want to see which areas of your treatment unit are being treated in the selected treatment ID, you click the Show Treatment Polygons, and then it'll show in the post-treatment map. So for example, in this site, areas inside these polygons are the ones that we will be affecting treatment on. Similarly, for the California spotted owl and the northern goshawk, we use a hexagon territory-based modeling approach where we are looking at the occupancy at a hexagon level. These hexagons are about the same size as a spotted owl territory, and you can toggle showing those on and off using this show hexagon polygon checkbox. Finally, for the California spotted owl and the northern goshawk, you can calculate the confidence interval around the number of expected occupied territories. So if you look in the model details on the bottom left, you can see that we have 3.13 expected occupied territories, and you can check that box and click update treatment to get a confidence interval around that number. This is optional and takes a long time to calculate, so we have it off by default, but if it's important, you can turn it on to understand the confidence intervals around that. This number of expected occupied territories is the sum of the values for each of the hexes weighted by the amount of the hexes occupied by the shapefile. In terms of understanding treatment effects, we have a set of metrics that can be modified in order to understand how that would affect species occupancy or habitat quality. The first thing is prescribed fire. If it is yes, we are assuming in the models that there is 100% of the polygon for that treatment ID that has been burned in low to moderate severity in the last 2 to 5 years. For the other metrics, there is a measurement of volume, and this can be basal area or quadratic mean diameter or stand density index. We chose 3 different metrics that are commonly used as measurements of volume, residual volume in prescriptions used by managers. You can only use one of them. So you choose either basal area, quadratic mean diameter, and stand density index, and this graph below will update to match the metric that you have selected, as well as canopy cover and canopy base height. We selected metrics that we feel are commonly used in management. This treatment effects are not modeled at an individual tree level, and so you need to input values for all the metrics in order to have a reasonable treatment prescription. For example, if you reduce the basal area significantly without reducing the canopy cover and click Update Treatment, that will feed into the model directly, even though you can't reduce basal area without reducing canopy cover. So you must put reasonable targets for your different prescriptions. So, for example, with a reduction in basal area, you should also put in a reduction of canopy cover based on the prescription that you have set. Similarly, you should change canopy base height based off of the prescription. As you can see, when you change the value of the slider, the graph turns green. This is just a reminder to show which ones you have updated or not. And then the graph shows the distribution of values that are observed in this treatment ID. If you change to a different treatment ID, now you're seeing the treatment effects for that different ID. And if we change back, you can see that it is storing the values that we set for the aerial treatment ID. Now that we have set some treatment values, we can click Update Treatment, and we'll wait for the models to reprocess, at which case the maps will update. If the values that you entered for your prescription create values in the models that are outside the range of conditions observed when defining the models, you'll get a little warning. This just means that the model performance is uncertain in this zone, and caution should be taken not to overinterpret the results of this. For more information on that, refer to the manual. As you can see, occupancy has changed. In some areas, we have increased occupancy. In other areas, we have decreased occupancy. And if we want to reset the values to their initial settings and start over, we can click Reset Treatment. The next panel on the settings, we can export some data. In this image, you can export an image of the map for the pre-treatment condition. This one will export an image of the map for the post-treatment condition. If you click this one, it'll export an image of the map for all the species. This one takes a lot of time, but you can then run your prescriptions on all the species and download in batch all the results. And then if you have set your prescriptions and you are expecting to come and work on do further work on the project area in the future, you can click this button, which will save the treatment settings. And then in the future, when you load your shapefile, you can also upload the treatment settings, and that will automatically populate this tab with all the information from your previous session. You can click this help button to get a detailed description of all the different settings for the treatment selection. Many of the features have tooltips, and so if you're unsure, you can hover over your different sections and get a little tooltip. On the Analyze tab, again, we're seeing distributions and histograms and summary statistics for pre and post treatment. And you can also see the range of condition observed in pre-treatment and post-treatment, basal area, canopy cover, and canopy base height compared against a reference condition. The reference condition is a data set of sites that have been identified to have an intact fire regime. So we're looking at resilience to fire as our reference. And you can compare the range of observed values in the project area against the range observed in the reference condition using these 3-box and whisker plots. On the right, you can further refine this by seeing that we have 60% of this project area is in warm, dry, low montane climate class. and 40% is in warm mesic low montane. When it shows all reference, we're comparing against the entire distribution of reference sites. But if we subset to a different climate class, we can compare our treatment area against just that climate class, which can give us a more refined observation. Similarly to the Visualize tab, we can export CSV tables of the summary statistics, images of the histograms, and you can also export the graphs of the resilience reference condition using this last button. This has been a short introduction to the FACET tool. For more information, refer to the manual or contact the developers. And we hope that this tool can help support your projects. Thank you.